Hello everyone, we are from Team NYASU. Our project is application of magnetism in cars. In our presentation, first, I will introduce you about our project. What inspired us to do this project? Second, we will go in detail to know more about the structure of the system and the operation principle. The third, I will show you what have we achieved from this project. And the fourth is the development of our projects in the future. First, let me introduce you about our project. As you know, the applications of science and technologies to manufacturing and services is becoming increasingly popular and effective in today's economy. The productivity of industries and people has increased multiple times as a result of new inventions and issues in life are being solved, consequently enhancing people's quality of life. And many investors have found that electromagnetism has a great potential to solve our issues. And to talk more about electromagnetism. As you know, magnetic systems have been used in many different areas around the world, including in logistics. For example, like the magnetic conveyor belts in industrial systems. In medications, electromagnetism is also an application in many medical items, and especially the application of electromagnetism in making vehicles, like magnetic levitation trains, is known as maglev trains, and maglev trains is also inspired to do this project. About maglev train, there are some well-known train systems using electromagnetic energies for operation, such as the Transparent of Germany, the linear Shinkansen, which is the maglev train system in Japan, and China has currently made their own maglev train system named Shanghai. Our team was inspired by the convenience, breadth efficiency, and the speed of these maglev trains. We wonder if we can make something that can be operated by electromagnetic energy. And then we decided to design a small electromagnetic car. So, first of all, let me tell you to know more about what it is there on our electromagnetic car system. As you can see, this is our first prototype of an electromagnetic car system. Most of the items we used were from a popular kit for Vietnamese library students. For the first part is the frame of this system. It has a length of 27.5 centimeters. The width is 12 centimeters, and you can see the interval between two electromagnets is about 9 centimeters. On two sides of this frame, we have set electromagnets symmetrically. These electromagnets would repel the magnet set on the car, then make the car move forward. Additionally, we have set on effect sensors for detecting the presence of magnetic field and then allows against the current going through the electromagnet. Following the horn sensors are MOSFETs which can close quickly with high currents and voltage. They are widely used in automotive electronics, particularly as switching devices in electronic control units, a power converters in modern electric vehicles, and as amplifiers. The second part is the car. This car has the length of 6 centimeters, the width of 10 centimeters, which is fit enough to the back, and the height of this car is 6.5 centimeters, as you can see. Especially on the top of this car, permanent magnets have been attached to this car to interact with the electromagnet on the both sides of the frame. So, how can this car operate by this system? In details, this car is simply operated by the interaction between magnets on the car and the electromagnets on both sides of the frame. To understand about this principle, let's sketch it on a coordinate system. As you can see, repulsive force in the system is F1 and F2. We then divide them into two components. That means we will check it on the x-axis and y-axis. Because the resultant force on x-axis is equal to 0, but the resultant force on the y-axis is not 0. Therefore, the car can move forward. Using electromagnetic system uh, can help us to reduce the friction force. So I think the frictions in this system is insignificant. Apart from that, there's also some resistance force from the floor, from the air, and from the electric induction. And so, what have we achieved from this our products and from this project? And this is our result. As you can see, this is the first prototype of us, and there are still some problems. The first problem you can easily see is that the motion is not continuous. Maybe it's because the interval between two electromagnets is not near enough, or maybe about the friction from the floor that make the motion is not smooth as expectations. And the second, when we do this experiment, we easily recognize that there's a large amount of heat release from the system, especially electromagnets. Maybe it's because of the Foucault currents that transfer electric energy to heat. Therefore, I mean the time using this system is not quite long, and we afraid that the many items will be broken due to the large amount of heat released from the system. And about the development in the future, I recognize that the rate potential of electromagnetism. So in the future, with the better conditions, we can develop this idea to make something that's more significant, more efficiency, like the magnetic conveyor belts used in industrial system or something like that. Um, Actually, there's still something that we cannot apply to this project due to our knowledge limitations or due to the COVID-19 that make us can't meet each other to do this project, which is the magnetic levitation in a car. We can make the car float in the air. Um, Unfortunately, due to COVID-19, our team can't finish the product as well as our expectations. But in the future, with a better condition, and I hope that we can do this project more perfectly. And thank you for listening to our presentations.